Mars is weird. Yes, it's the most studied planet beyond Earth, and we humans have sent there more spacecraft than to any other planet. We have maps of nearly the entire surface with very high resolution. For example, here's a 5.7 terapixel map where each pixel corresponds to roughly 5 meters of surface, and this map covers 99% of the planet. Of course, that's still far from everything. Observations from different orbits and across different wavelengths, radar studies that probe to a certain depth beneath the surface, images from the surface and various experiments conducted by rovers, seismological studies, and so on and so forth. In general, we know quite a lot about the red planet. But, as often happens, the more information we have, the more mysteries there are. Yes, new high-quality data sometimes help solve old mysteries. Remember the face on Mars, in the images from the Viking 1 spacecraft, which turned out to be just a mesa. And as detailed images from the MRO spacecraft later showed, the result of light and shadow playing tricks at a certain viewing angle. Well, okay, there is no face there, but there is a pentagonal pyramid, which also appears to be just a natural geological formation. There are many more similar examples. Just like at even smaller scales, when individual rocks or boulders in certain images resemble something that we don't expect to see on Mars. All kinds of humanoids, doors, frogs, flowers and corals and so on. But today we're not going to talk about that. There are plenty of peculiarities on Mars, not imagined ones, but the very real ones. For example, those that won't disappear when the viewing angle changes or under different lighting. And most importantly, oddities on a completely different scale. Those that affect a significant part or even the entire planet. Some of these oddities can be noticed even by untrained people just by glancing at a global map of Mars or at certain images of the planet. And today we'll talk about several of these features or phenomena occurring there. Some of them still have no clear explanation. How did the ice spiral form? Why are giant volcanoes aligned along a straight line? Why is Mars two-faced? And what are those dust towers tens of kilometers or miles high, and how do global Martian storms form? We'll talk about all this and more. I'm Andre, and this is Cosmos Elementary. Looking at images of Mars like these, it's hard not to be drawn to the three giant shield volcanoes, aligned basically along a straight line. They stand out even more on global elevation maps. Often all the attention goes to their neighbor, Olympus Mons, and for very understandable reasons. The tallest volcano in the solar system, nearly 22 kilometers or 16 miles high. Imagine a volcano so massive that its area is comparable to that of a not-so-small country like Italy. It regularly appears in all sorts of the biggest lists, but today we're interested in its three neighbors, Arsia Mons, Avanis Mons, and Ascrias Mons. Together they are called the Tharsis Montes, named after the Martian region where they are located. Their heights range from 8 to 17 kilometers or from 5 to 10.5 miles. Not only are they arranged almost in a straight line, but they're also similar in size, ranging from 350 to 500 kilometers or 210 to 310 miles in diameter, and the distance between them is roughly the same, about 700 kilometers or 430 miles. Could such an arrangement really be a coincidence? Or could it be a giant Martian interferometer with antennas hidden there? But seriously, this really is a mystery. I mean, of course, you could just chalk it all up to coincidence. Remove even one of the three volcanoes and they no longer look so orderly, although even then there would be those who would spot triangles formed through Olympus Mons and the two remaining ones. But here's the tricky part. On the one hand, if you compare it to Earth, there's nothing really unusual about several volcanoes lining up in a row. That happens in many places on our planet. What's unusual is that it happened specifically on Mars. The question of volcanism on Mars has long been of great interest to scientists. On one hand, it's obvious that at some point it was definitely active on Mars. Across the planet you can find many volcanic formations that appeared either as a result of explosive volcanism or eruptions, or effusive activity, when lava gradually flows onto the surface. But is Mars active today? For decades, as more and more detailed images of the Martian surface taken by close-range spacecraft became available, scientists assumed that Mars was essentially dead. Even in images from the Mariner 9 spacecraft, volcanoes were discovered, but all of them were extinct. And to this day, we have never seen active lava flows on the surface of the red planet. Although that would be amazing. Just imagine in the rover images we might see not this, but something like this. Given Mars' characteristics, its current dead state isn't surprising. Active volcanoes require a sufficient amount of heat within a planet's interior. Apart from radioactive decay, the main source of heat is the heat left over from the planet's formation. And naturally, it's not infinite. Planets slowly cool down over time. And being smaller in size, Mars should cool down faster than Earth. However, according to recent estimates, even if we don't observe obvious volcanic activity right now, it may have existed on Mars relatively recently. There are quite a few areas of relatively young surface. We can't measure their age precisely, but by the number of craters, which should be more abundant on older surfaces, we can make rough estimates. And a combination of surface image studies, radar data obtained by the InSight spacecraft on Martian quakes, which still occur today, plus computer modeling, all that suggests that volcanism could have been active as recently as just 1 million years ago. In geological terms, that's practically yesterday. And maybe there are pockets of magma beneath the planet's surface even right now. It's even possible that our observations just happen to coincide with a quiet period, and then one day it will get somewhat active again. But let's get back to our trio. On one hand, Mars shield volcanoes are similar to shield volcanoes on Earth, both in appearance and in their formation mechanism. From the depths of the planet, from the mantle, from hot spots of long-lasting volcanism, magma rises, reaches the surface, solidifies, and then more and more follows. The solidified lava layers build up and the mountain grows. The 3 volcanoes on Mars are, in some articles, compared to the volcanoes in Hawaii, which are also arranged almost in a line. By the way, on Mars, it's not just these 3 volcanoes in a line. There are other formations further along, though they aren't as large or noticeable. And we understand how this happens on Earth. Lithosphere, the outer shell of our planet, consisting of the crust and the upper part of the mantle, is not a single continuous layer. Rather, it's made up of separate plates, each of which moves independently. That's why the appearance of our planet is constantly changing, continents and oceans shift, mountain ranges grow and erode, and many other important phenomena are connected to this. And contrary to a common misconception, which I've even seen in some popular articles, the Earth's mantle is not made entirely of magma. It mostly consists of what would simply appear to us as rock. But within the mantle, there are pockets of molten rock, magma, that feed volcanoes. In the area above such a pocket, magma erupts to the surface and the shield volcano begins to grow at that spot. However, the tectonic plate does not stay in place, and over time the volcano that has grown moves away from the magma source, along with the plate. But the magma has to go somewhere. Under certain conditions, it erupts again at a nearby location, and a new volcano begins to grow. This is how an entire chain of volcanoes forms, roughly aligned along the movement of the tectonic plate, just like what we see in Hawaii. And as I mentioned earlier, on Mars the arrangement of these volcanoes is compared to the Hawaiian volcanoes. So here is the mechanism for the even spacing of volcanoes along a line. The only problem is that, as far as we know, Mars' outer shell isn't made up of separate independently moving plates. Its crust forms a single continuous layer. That's exactly why these shield volcanoes, along with Olympus Mons, are so enormous. The crustal section didn't move away from the magma source, so magma kept erupting in the same spot and the volcanoes kept growing. Plus, Mars' weaker gravity helps as well. On Earth, because of gravity, erosion, and other factors, it's hard to imagine mountains reaching such heights. But on Mars, it's entirely possible. The volcanoes in the Tharsis region have been studied in quite some detail. They are clearly very ancient, having formed billions of years ago. Yet, it's possible that they were active not too long ago. In this paper, scientists estimated the ages of different areas within the volcanoes, and there are both younger and older sections. This is a map of the entire region showing areas corresponding to different geological eras. And here are more localized age estimates. For example, in the caldera of Ascrius Mons, we see several areas whose ages differ by hundreds of millions of years, with the youngest being less than 200 million years old, which again is relatively recent in geological terms. Arcea Mons is even younger. If dinosaurs had a space program, they would have captured the formation of some of these areas. Considering that along this line, besides the 3 volcanoes, there are other features as well, the arrangement is clearly not accidental. But a mechanism like the one on Earth cannot explain this. It's probably some kind of structural feature, a weakness in the crust in this area, but why it formed, we don't know. Although there's one interesting idea related to another well-known Martian mystery, namely its so-called dichotomy. Given that we've established that planet's crust isn't divided into plates, when you look at topographic maps like this, one thing immediately stands out: the clear difference between the northern and southern parts of the planet. About a third of the planet's surface located in the northern hemisphere is, first of all, much lower. The average elevation difference between the hemispheres is a full 5 kilometers or about 3 miles. But the difference in crust thickness is even greater. In the southern hemisphere, it's on average 26 kilometers or 16 miles thicker than in the north. The surface characteristics also differ. The south has more mountains, irregularities, and craters, while the north has many plains, a smoother surface, and fewer craters. Most likely Mars has looked like this for the majority of its history, and this dichotomy is very ancient. There are several theories about its formation, some related to external causes, some to internal ones, and some to a combination of both. External explanations include the impact hypothesis. Such a difference could have been caused by a massive body colliding with Mars, or by multiple smaller impacts. Internal explanations involve processes occurring within the planet's interior, particularly convection. On Earth, tectonic plates move partially because warmer rock in the mantle slowly rises toward the surface while cooler rock sinks, creating convective cells that drive the plates. On early Mars, shortly after its formation, something similar could have occurred. But there may also have been a special type of convection, where a single giant cell operated in the planet's interior. In one hemisphere, material would rise, while in the other it would sink. This could create asymmetry, differences in crust thickness, and overall distinct properties between the hemispheres. But as I've already mentioned, there are hypotheses that combine both mechanisms. Such convection could have been triggered by a giant impact. Additionally, a giant magmatic superplume could have formed in the planet's interior, and the migration of such a plume toward the southern hemisphere could explain not necessarily the alignment of individual volcanoes, but the emergence of the entire Tharsis volcanic province. So there could be a connection between an ancient massive impact and the formation of these enormous volcanoes. Over 50 years ago, the Mariner 9 spacecraft, which I mentioned today, reached Mars, and among the images it sent back was this one. This is the northern polar ice cap of the red planet. Here's a more recent image, and of course, the unusual structure of the polar ice cap immediately catches the eye, especially the depressions arranged in a spiral. If we take an image showing the North Pole, we can see that these distinctive spiral arms radiate outwards precisely from the North Pole. Scientists have long tried to solve the mystery of the spiral, and there are some plausible explanations now. It's funny that conspiracy theorists haven't thought to build some kind of theory around the spiral. Well, guess I shouldn't have given the idea, huh? On the one hand, in the universe we see many spirals forming naturally at a wide range of scales, from the largest, an obvious example being spiral galaxies, to smaller ones like protoplanetary disks, and even smaller hurricane vortices in planetary atmospheres. But all of those are structures made up of a vast number of individual elements: stars, gas particles, dust particles in clouds, or some atmospheric phenomena. Here, however, we have a spiral in a solid surface, in the Martian polar ice cap. How could it have formed? Interestingly, there is likely something in common here with atmospheric phenomena. The northern polar ice cap itself is mainly made of water, more precisely water ice. It's a couple of kilometers thick, and the depressions that form the spiral aren't continuous long valleys. Rather, they consist of individual cells. Here's a detailed image where you can see the edges of such two cells, and the ice between them. Interestingly, the spiral isn't always so clearly visible. During the Martian winter, a significant portion, up to 30% of planet's atmosphere, which is mostly made of carbon dioxide, freezes and covers the polar region with a layer of dry ice, up to 1 meter or 3-4 feet thick. In this image, we can see that the ice cap has expanded and the spiral is less visible. And here are the images of Mars' North Pole taken at different times. The quality isn't great, but you can see how much this region changed visually and that the spiral can be distinguished only here. There is also this large formation in the polar ice cap, which is possibly older than the spiral. But still, how did this spiral form? Now compare this with this. Does it look similar? Yes, the Martian spiral is solid, while an Earth hurricane, well, that's a hurricane, an atmospheric phenomenon. But there's something they have in common. Today's prevailing theories for the formation of the spiral are mostly linked to wind. What sets them apart is that in some cases the formation of the fractures is attributed to erosion and breakdown, while in others it's explained by the gradual layering of new ice. But in both cases, an important factor is the katabatic winds and the Coriolis effect. We're talking about certain types of winds when the airflow moves from top to bottom along slopes, and the polar ice cap is higher at the center than at the edges. In that case, we would expect the wind to move from north to south. But the planet rotates around its axis, and that's where the Coriolis effect comes into play. The effect also influences hurricanes on Earth. As a result, the wind doesn't move strictly southward, it also shifts westward, which leads to the formation of these spiral arms. The wind either slowly erodes small depressions forming the individual cells that line up into the spiral arms, or it asymmetrically deposits layers of ice. Of course, there are still many details, but here, unlike with the line of volcanoes, the mechanisms that could create this amazing structure are at least fairly well understood. On Mars, towers reaching many kilometers or miles in height can grow and then disappear just as quickly. That's because these towers are made of dust. Dust on Mars is, on the one hand, a fascinating thing, and it's linked to many mysteries. But at the same time, it's also very troublesome and has already taken out more than one spacecraft on the Martian surface. Let's press F to pay respects for opportunity and insight. Many people constantly complain about this, asking why NASA doesn't add some dust cleaning systems to the spacecraft so it could operate longer. First of all, it's not as simple as it seems at first glance. The dust particles on Mars are very small. They don't just settle on the surfaces of spacecraft, but also stick to them due to static electricity, much like tiny pieces of styrofoam. So simply brushing off or blowing away the dust may not be as easy as it seems. But there is another reason. Considering how expensive it is to send a scientific spacecraft to Mars and that every gram costs a lot of money, scientists and engineers have limited resources. They have to make a choice. Either design a cleaning system and include it on the spacecraft, which would take up precious mass and consume energy, or add one or more scientific instruments and hope that the spacecraft operates for the planned mission duration. Many spacecraft have still operated even longer than their planned lifetimes, and sometimes they were cleaned of dust naturally by the wind. In general, the choice hasn't been made in favor of cleaning systems yet. But yes, dust can be a problem, and if humans ever do travel to Mars, something will have to be done about it. The dust towers I mentioned are linked to dust storms, and especially many of them form during global storms. By the way, we still don't fully understand these, and they're connected to another unsolved Martian mystery. Dust storms also occur on Earth, and some aspects of Martian dust storms are fairly well understood. A wind is needed to lift dust from the surface into the atmosphere. For wind to arise, a difference in temperature is also required. We already talked today about the polar regions, and there, near the ice caps, local dust storms can also start. For example, here's a series of images near the polar ice cap where we can see local dust storms. Can you guess what might have triggered them just by looking at these images? I've already given a hint. A temperature difference is needed. Around the ice of the polar cap, we see a noticeably darker surface. It absorbs more sunlight and accordingly heats up more. A significant temperature difference arises, which generates fairly strong winds in the region. This is just one example in a single area, but in general, rising warm air currents create phenomena of all sorts of scales. From small whirlwinds or dust devils like those you can see in these photos and animations taken from the surface of Mars, to fairly large dust storms, which can be comparable in size to entire continents. They certainly look epic even in images taken from orbit rather than from the surface. On Mars, such storms last longer, thanks in large part to the thinner atmosphere, which has only about 1% of Earth's atmospheric density. Dust particles lifted by the wind from the surface experience much less air resistance. Plus, Mars' weaker gravity adds to this effect. As a result, the particles stay in the air much longer, and dust storms can last for many weeks, sometimes even months. Additionally, Mars has no oceans, which on Earth acts as a kind of dust trap. But sometimes large storms merge or grow to planetary scale, when a veil of dust envelops the entire planet. Mariner 9 spacecraft, mentioned several times today, arrived at Mars right in the middle of such a global storm. At first it didn't see much of interest, except perhaps for Olympus Mons. NASA specialists had to wait about a month before they could start mapping the planet. So what's the mystery of the global dust storms? On the surface, we seem to understand the mechanism fairly well. Moreover, we also see that the largest storms usually occur during summer in the southern hemisphere. Mars' axis of rotation, like Earth's, is tilted actually quite close in angle, about 25 degrees compared to Earth's 23.5 degrees. On Earth, the main factor for the changing seasons is precisely the tilt of the axis of rotation, not, as many think, the distance from the Sun. The idea that closer to the Sun is summer, farther away is winter, is a common misconception. Interestingly, on Mars, in addition to the axial tilt, the distance from the Sun also becomes an important climactic factor. Mars' orbit is much more elongated than Earth's. Its eccentricity is 5.5 times greater than that of our planet. At its closest point in orbit, the perihelion, Mars is nearly 43 million kilometers or about 27 million miles closer to the Sun than at aphelion. This occurs during southern summer, when the planet receives more heat, and it's precisely during this period that the largest storms tend to form. So far, everything seems to make sense. At the same time, overall weather on Mars can be fairly predictable from season to season. But the problem is that global storms don't occur every year. They appear on average once every 3 Martian years, or roughly every 5.5 Earth years. Why there is this gap of several years is still unknown to scientists. It is possible that there is some kind of cycle during which dust accumulates precisely in the areas needed to trigger a global storm, but that's just a hypothesis. As I mentioned before, dust towers are linked specifically to large storms. They don't appear only during global storms, but most often they are observed in them. In this photo we can see one such tower. It's a vertical dust formation where the concentration of dust is higher. It starts at the surface and rises to a height of about 80 kilometers or 50 miles, almost reaching what we could practically call space. During large storms, they are constantly replenished with dust and can last for several weeks. Interestingly, they may also be linked to another Martian mystery, the disappearance of water. In small amounts, water exists there as ice in the polar caps, and some is also beneath the surface. But it's believed that there used to be much more of it. The upward currents in these towers can capture water vapor particles. At high altitudes, they are broken apart by solar radiation into their components, and then hydrogen escapes into space. Scientists have detected evidence of this process. As a result, dust towers can act like a sort of space elevator for water, allowing it to escape from Mars into space. On Earth, given the nature of our atmosphere, something like this wouldn't work very well. There are so many mysteries and interesting places and phenomena on Mars that this video could easily be 10 hours long, if not more. So I think we'll get to it in the future, as well as to the mysteries of other planets.